The other type of chi-squared test that comes up besides goodness of fit is chi-squared test for homogeneity that tests to see if opinions the same for multiple groups, or independence that tries to test to see if there's a relationship between multiple variables. I have an example here where I want to test if student opinion is the same for multiple groups. I'm looking at math, art, and history, and I'm wondering if people love, hate, or don't know who our school mascot is. I'm going to start with GeoGebra this time around just to kind of show you what the general process is like, because it has less steps in GeoGebra than it does in the calculators. So I'm going to probability, I'm going to statistics. This is where I've done all of my tests so far in GeoGebra. I've actually done almost everything now inside of GeoGebra for these options. In fact, the only thing I've not done is this chi-squared test. I'm starting with my observed values here, and I'm just typing those inside numbers of 20, 80, and 100 for math. For art, I have 40, 60, and 200. For history, I have 40 people love Poppy, 160 people hate Poppy, and 300 have no clue who Poppy is. I've typed in my data here inside of GeoGebra. It immediately gives me my degree of freedom of 4. It gives me my chi-squared value of 28.22 repeating, and it gives me a p-value of 0 plus. If the p-value is low, the null must go. So this tells me that their opinions are not the same for each of those groups, that there's some sort of relationship between degree and if you like or dislike Poppy. If you clicked this thing on expected counts, this would actually show you where those differences happen. So looks like math is reasonably close except for the hate and don't know numbers are a little bit off. It looks like for art, off by 10, this is off by 30. That's a fair amount of error. So there seems to be way less hate in the art department than anticipated. Way to go, art department. History, they're off by 10 for most of the categories, except they're spot on when it comes to not knowing who the heck Poppy is. So inside of GeoGebra here, all I had to do was choose chi-squared test. I type in my raw data, and then it gives me my degree of freedom, my chi-squared, and my p-value. Your rows go side to side, like if you row a boat. If you have more than 3, you can change the number of rows. Your columns are like columns of a building. Columns go up and down. So if you had only 2 columns, or if you had up to 5 columns, that's something you can change pretty easily. Now, if I'm doing this in a graphing calculator, this is going to be a 2-step process, because the first thing I have to do is type in this grid inside of my calculator called a matrix. And then I'm going to have to go through the normal test process that I've done for all the other calculator videos thus far. So let's look at the TI-89, and I'll step you through the process here. So inside of the TI-89, I'm going to do something different. I'm going to go to apps. And almost every other time, I've just started inside of StatList Editor, but I have to do a pre-step here. I have to go inside of Data Matrix, and I need to make a grid where I'm going to be typing in these numbers. It asks me current, open, or new. Let's go ahead and make a new matrix. For the type, we want to make a matrix. A matrix is a grid of values. And I'm typing everything in this top grid that I have here except for the total. So I'm going to choose a 3x3 matrix. Variable name, you can call this thing whatever you want. So I can name this, for example, Pop. I named it Pop for Poppy, so I'd be able to remember this thing pretty quickly. Literally any name is fine. 3 rows and 3 columns. I hit enter. And now I have a spot to type in these values. So I had 20, 80, and 100 for the math department. I had 40, 60, and 200 for the art department. And I had 40, 160, 300 for the history department. I have now typed in my matrix. I can go back to what I normally do, which is stat list editor, test, and then just choose the name of the test. So let's do that. Apps, alphabetical order, so I'm just scrolling down to S until I find stat list editor. My tests are up top. My tests show up in F6. And I'm doing something called a chi-squared two-way because I have a grid of values. It's going to ask where my observed matrix is. Reminder, all of my variables live inside a variable link. Do you see how that's in blue? I'm going to hit second and variable link to pull up a list of all of the names of the things I have typed into my calculator. And I'm going to scroll through and I'm looking for pop. There it is. This is Poppy, and it's that matrix. MAT stands for matrix. That's what I'm looking for. I don't touch anything else. I don't need to touch anything else. The observed matrix, that's the name of the thing that we just made. I hit enter. This gives me my chi-squared value of 28.222. It gives me this p-value of 0 plus, really small, and it gives me a degree of freedom of 4. I'm getting the same results as before. I just had to do an extra step on the calculator where I'm typing in those matrix. Let's do the same thing now for the TI-84. And the 83 works the same way. I'm going inside of my Smart View. I can download a trial of this thing if I don't have it. And I'm going to try to find matrix on my calculator. Now, I notice that matrix shows up right here in the blue. So I'm going to hit blue matrix to go inside of these options. Inside of matrix, I'm going to go over to the edit option, and I'm going to hit enter to edit this first matrix. I had 3 rows. Rows are the side by side, that's that first value. And I had 3 columns. I type in my numbers, so I had 20, 80, and 100. I had 40, 60, and 200. I had 40, 160, and 300. Now that I've typed this in, it's back to business as usual, which is great. I'll go stat. I will choose the option for test. I'll scroll down to the bottom. I'm going to cheat just by hitting the up arrow. And I'm going to choose chi-squared test. This is chi-squared two-way, even though it doesn't call it that. It asked me where the observed matrix is. Well, I always just change A, so I actually don't have to do anything else except go down to calculate and hit enter. This will immediately give me my chi-squared value, or my test statistic. That's another name for this thing, 28.22. And it gives me my p-value of 0.00001. It's so small we would call this 0 plus. If your p-value is low, the null must go. I would reject the claim that there is a lack of relationship between the variables. I have evidence that there's some sort of relationship between program and whether you love, hate, or don't know who Poppy is. This was how to do chi-squared homogeneity using a calculator and GeoGebra. I'm going to show you how to do something similar for comparing multiple averages. That process is called ANOVA. That stands for analysis of variation.